In this video, we will talk about Temple. I have made a video or two in the past in this channel about Temple, but this video will be more of a comprehensive review of this tool. What is it? Why using it? How is it compared to other alternatives? And how to actually install it and use it and write our first component and render it. So let's get started. What we will cover in this video, basically what I just said a few minutes, you can just pause the video and see the coverage of this video. All right, so let's get into it. So what is Temple? Well, Temple is an HTML templating language for Go. It allows you to write your HTML syntax or your HTML tags inside Go files in Temple files that are acting similar to Go files. And then the compiler will go ahead and convert your Temple components into Go code that you can actually access anywhere in your program very easily via functions and render your HTML whatever you want in your program. So it lets you write HTML templates that are compiled directly into a efficient Go code. So this will allow you to catch errors basically in compile time. It will allow you to use your Go variables inside your HTML tags. It will allow you to use Go syntax to conditionally render your HTML tags. Very useful. All right, so what are Temple's unique features, let's say? So first feature is that it is compiled. So when you write your templates, you don't just interpret them at runtime, which makes it slow and also not so safe. You actually compile them into Go code, and then you use that Go code, those functions that you have, to render your HTML, which makes it much more type safe and also very much faster. And then it has a great components model, meaning you write your code or you write your applications in components. And we've seen this before with other, frameworks like React, like Vue, other web frameworks, where you write your application in nodes layout, meaning you have the layout of the application, the main component. And then inside of this component, you might have the head component of the HTML. You can make this as a separate component. You can have the body, again, as a separate component. You can have footer, you can have header, and other components as well. So this makes it very much unique in Temple, but it's not unique in web frameworks, but it's unique to this tool as in Go ecosystem. It also has a great developer experience, and this comes from the type checks at compile time, but also the fast compiling, with the tool, and also the actual use of the LSP, which is the language server protocol, which allows you to catch syntax errors before you compile and also catch type safe errors or safety errors. All right, so let's cover how does it compare to, for example, the standard library HTML template, right? Well, again, this one is compiled, Temple is compiled, so it will be much more type safe and also much faster, while the other one is interpreted, which makes it slower, but also not that safe. The Temple has a much more structured components model when you can, divide your application into components, while the other one does not. And you kind of like write it into like inside your Go code, and it's not that convenient. Temple has a lot of speed that allows you to check syntax errors before compile, while the HTML template does not. All right, and also, again, you can use Go code to render. There is no weird syntax into Temple. You can use your Go syntax to conditionally render your template, while the HTML template, you kind of have to learn the HTML template kind of way of doing. There is a learning process in Temple, but it's very much smooth because it's similar to Go in every way possible. All right, so let's just go ahead and cover installation right away. All right, so to install Temple, we need to install two things. If we go to the installation page in the documentation, we can see that we have to install the Temple CLI. And we can install this CLI in two ways. We either install it globally in our system via the Go install with this link, or we can use it as a tool. And I'm going to cover this one because I like to install it as a tool locally in my project. All right, so let's just jump into the code. So we go to the terminal. And here we're going to actually create a new directory for our new project. So I'm KDIR. I'm going to call this directory try Temple. This will be a Go project. So I'm going to change directory into this directory, into the new created try Temple directory. And then we're going to use Go mode init to initialize a new Go mode. Now, of course, if you don't have Go installed, you have to actually install Go. After we created our Go mode and actually initialized our Go project, now we can go ahead and install the tool. And we can install the tool via go get flag tool, and then give it the link of the tool, which will be under github.com. So to github.com, then then Templ, then cmd, and then Templ at latest. Then press enter. We wait for the tool to be installed, and then now we have the Templ tool or the Templ CLI. To check for the Templ CLI installation, we can go ahead and run go tool and then the tool Templ that we just installed, then the version command to check which version that we have installed. And we can see that we have this version at the time of the recording of this video. Now we can install the package of Templ via go get, and then we give it the link of the package, which will be under github.com, then then Templ, just like that. Now we have the package installed and the tool installed. Now we can actually go ahead and jump into and open up our editor. I'm going to use Vim here, and we can create our first Templ file. We can call it, for example, hello.templ. And this file would be just like any other Go file. You would actually define your package name. This will be the package main, and we can write any Go function here, or Go syntax here. So Go function, constants, variables, everything works here, and also import statement just like any Go file. The only difference between Templ file and a Go file is the actual addition of the keyword Templ, and this keyword will allow you to actually create your component with Templ. So we will create our own first component. We will call this component hello. This component will take an argument that is maybe a name that is a string of type string, and then we'll open up curly brackets. And this Templ keyword, will think about it as like a function that returns HTML. So you have to actually in the open brackets or in the body of this Templ component, you actually have to render HTML. So we'll use some HTML here, for example, the h1 tag, and I'm going to say hi, for example, and then use curly brackets to use the argument that I just defined, but that is the name argument. So I'm going to call this right here, just like that. This is basically our first Templ component. We created this component via the Templ keyword. Now let's take a look at how to render this component. Before rendering the component, we have to generate the Go code out of this Templ file, because now we have only hello.templ as the Templ file. We have no way of using this component actually in our application. And to actually use it, we go back to the terminal. We have to generate the Go code out of this Templ file. And to do that, we use the Go tool Templ and then generate the command generate to generate the Go code. You can see that here it says complete. And if we list our files here, we can see a new file ends with Go with the same name of our Templ component. That means the actual compilation is successful. Now we can actually render our component. To do that, we open up our editor, we go and create our own main.go file. In this main.go file, we open up package main, and then here we actually write our main entry for the application with the main func, and here we actually going to render our component. So to render our component, we simply call it just like that by its name, which will be just like that as a function. Then we give it the arguments it needs. In this case, it needs some name, so I'm going to give it AT, and then we can use the method of render to render this component. This render method takes two arguments. It takes the context, in which context it will render this component, and the second argument would be the actual writer, which writer it will use to render the component. The context, in terms of the context, we don't have a special context here. We're going to use the context.background, and in terms of the writer, we're going to use os.stdout, the standard output, to render this component into the output of the terminal. So we go back into our application, we use the command go run dot to run our application, and now we can see that we are successfully seeing this h1 tag here in the terminal, meaning we successfully rendered our component to the standard output. Next, we will see how to actually create index.html, like static files, and render our component into these files. All right, so to actually try to create HTML files using our Templ or templates, we need to actually create a file first, that is index.html, and then render our component to this file. So I'm going to actually try to do that. we're going to go ahead and create another component. This will hold some boilerplate HTML just to have some actual HTML in our index.html or the file that we're going to create. And so in this HTML component, I'm going to just fill it with some boilerplate HTML just like that here. And then in the body, I'm going to call our component that we just created, the hello component. So we can call it via this key. This key will allow you to nest other components inside another component in Templ. So I'm just going to call it this way and then give it the argument maybe from HTML, just like that. Now we have this new component, so we need to actually generate you run the command Templ generate to generate the Go code for this specific HTML component. And we go back here, we run this Go tool Templ and then generate the new HTML component. Now we can go back to our application and create our file that we want to render those components to. So we're going to go ahead and define file, and error comes from os.create. We give it the index.html, and then we're going to check the error. If error does not equal nil, then we go to actually log.fatal that error. And then we're actually going to defer closing this file so we don't have this file open after we are done using it. Then we are going to call the new function that we just created, or the new component that is HTML. Then we render this component with the context background and the newly created file. So we can also check for errors coming from this component, just to be extra careful or fancy or whatever you want to say. So log.fatal error. All right. We can also be extra fancy and give it a little bit of a printing here, just to tell us that is successfully created index.html, just like that. Now if we go back to our application, clear the terminal and run our application via the go run dot, we can see that we have successfully created index.html. If we list our files, we can see a new file created here. And if we open up the editor again and maybe try to find this file, format it in a way that we can read it, and we can see that exactly we have an HTML file with the body tag, and inside the body tag we have this h1 tag, comes from our other Templ hello component, and it has the hi from HTML, just like we defined here in our hello.templ, just like here, right here. So you can see how we can create static files using Templ, and how can we render our templates or components to a static HTML files. But now if we want to make a change here, let's say we want to maybe remove this word and replace it with world, like that, and we want to see those changes reflect in the index.html that we just created. It would be cumbersome if we have to just rerun each time. We have to just go back to the terminal and regenerate the actual templates using the Go Templ generate. Is there a better way, like maybe a watcher that watches our files and detect automatically the changes and regenerate the templates for us? Yes, there is a better way to do that. And so to do that, I'm going to actually split the screen into two halves. Let's just like that. So now we have this pane right here that I'm going to run actually the watcher here, and our editor will be right here. So to run the Templ watcher, you simply run Go Templ or Go tool Templ generate, then you give it the flag watch. This flag will allow Templ to watch the files or the templates and then automatically generates the Go code after it detects some changes in the templates. So let's go ahead here and make some changes. For example, if we open up this one, we actually made some changes. We made this world, change, but let's just say just like that. We can say hello world, just like that, a classic, right? So if we go back now and run our application, go run dot, we should see the latest update reflected in the index.html that is right here. If we format it, we actually can see that it says hi world, which is perfectly fine because that's what we did actually give it here as an argument. To make sure that the actual watcher is watching our files, so we can maybe change this hi to hello. just like that. And now after we save and we rerun our application, so let's just go ahead and do that. Go run dot. We can see that is successfully created. And now if we open up this index.html and format it in a way that we can read it, we can see the latest updates here. That is hello world. Now you can see how, kind of problematic it is to just go ahead and rerun up our application after each iteration, and after each update we have to actually run our application ourselves. So there is also a flag for that. So the flag for this will be the following. So now we're watching the file and only generate the templates after a change is detected, but we can actually watch two files. We can watch the templates of our application and regenerate the Go code after any change in the templates, but we can also watch the main.go file or our project files and rerun some command after those change. And to do that, we run the command go tool temple generate, then we give it the watch flag, then we actually include the CMD flag, and this flag will need some value. So you give it value by equal sign and then quotes, and here you actually put the command that you want to rerun after it detects some changes in the project files. So our command will be go run dot, just like that. And now it's watching our files and rerunning our program just like that. As you can see here, it logs out that we have created index.html. So now will be much more seamless development. If we want to update something in our templates, let's say that we want to change this back to hi, and then we save. We automatically, after we go back to the main.go, we save this main.go, we automatically see this log again that detects that we have actually rerun our application again. And if we go back to the index.html, we can see the latest updates just like that. So next, we will take a look at how to create our own HTTP server and how to actually render our components from that HTTP server. We will also take a look at how to render them with static data and with dynamic data. All right, so now if we want to actually create our own HTTP server, we go back to the main.go file. Let me just ignore this annoying file here. We open up the editor again and we go back to the main.go file. We create our own HTTP server, and this will be a simple server. So I'm gonna go ahead and define MUX that comes from http.newServMux, just like that. And here we can use this MUX to handle our routes, and we can use handle to handle the home route. And in the other argument, we give it the handler. And Temple actually provides another handler that will allow you to actually render a component right away with fixed data. So we can use Temple right here and use the handler of this Temple, package. And inside the handler, we can call another component, whatever component we want to actually render whenever we get a request to this route. So we will call this HTML component right here. And now let's run our server via the actual HTTP listen and serve. So HTTP listen and serve, and then we give it the port that we wanted to run our application with, and then we give it the actual router or our MUX. We can also print line, some line to just tell us that we are running this server at 5959, just like that. We could also go and delete the packages that we are not using, so we can satisfy the compiler and actually run our application. As you can see, the watcher automatically rerun the application on the port 5959. If we want to go back to the browser, let's say we want to go back to the browser here, and I'm going to access this new local host at the port 5959, we can see hi world just like that. Now, if we want to make some changes, let's see if we can make some changes and see the changes reflect here. So we can go back to the terminal, and then in our editor, we go back to the hello.temple. And here, let's say we want to change this hi to hello. We save and automatically go back to the browser. And then now we can refresh the page. We can see automatically the actual server reflected on these changes and gave us the latest change in the templates. And this happens because we have in our terminal a watcher that watches our files for these changes, just like that right here. Awesome. So now we have created our HTTP server, and we have responded to our request with some fixed data template. Now let's say we want to generate dynamic data, dynamic being as generated at the time of the request. So we go back to the main.go, and here we will add a new route. So we're going to go ahead and say mux.handlerfunc, and we're going to use handlefunc in this case to handle this route, let's say the time route, with a func. This func will allow us to actually dynamically handle this route at the time of the request. And so let's define a variable here. Let's call it now. And this variable will obviously hold the time.now, not November, but the time.now. All right. And we can use this to local. So now we have the time.now in the local time zone of the server. Let's say we want the string out of this, and we can use this string to actually render our hello component with that string. So we can call our hello component just like that. We give it the now string, and then we use the render function. To render a function within the HTTP server, you need to give it the context of the request, so r.context, and then you give it the actual writer of the HTTP response writer. So the W right here defined right here. Okay. So after we're done with that, now we should see that after we save, when we access the route of time, we should see the time of the actual request printed in the browser. So let's check on that real quick. So let's go back to the browser, and right here we can go to the actual route of time. We can see it prints out hello and this time string right here. If we refresh the page, we can see different time string, meaning this time is dynamically generated at the time of the request. This is definitely useful if you want to create specific content for each request and dynamically generate some data at the time of the request. All right, so this has been it for today's video. We took a look at some basics of Templ. We have created our own file, rendered the components in multiple formats, and then created our own HTTP server and rendered components from that HTTP server. So if you like this video, don't forget to hit the like button, hit the subscribe button, maybe keep a comment down below. Let's say, what other things do you want to see with Templ? And this was AT from More Than Coder. Goodbye. And also, don't forget to follow me on Twitter. I'm active on X or Twitter, journaling my journey into the world of programming. If you want to watch another video from this channel, you can check out this video recommended by YouTube. All right. Peace.